Friends, welcome to Acharya Gurukulam. Today's topic is reinforcement requirements for columns as per IS456-2000 and the clause is 26.5.3. In this video, I am going to discuss about the longitudinal reinforcement, transverse reinforcement and helical reinforcement of the column as per IS456. In this figure, the longitudinal reinforcement and the transverse reinforcement are shown, and the distance between two successive lateral ties is called the pitch. The cross section of the column is as shown at the bottom of the figure. B is the breadth of the column and D is the width of the column. The cross-sectional area of the longitudinal reinforcement shall be not less than 0.8% nor more than 6% of the gross cross-sectional area of the column. It means 0.8% is the minimum reinforcement to be provided and 6% is the maximum longitudinal reinforcement is to be provided. The minimum reinforcement limit is to ensure the flexural resistance under unforeseen eccentricity in loading, and also to prevent yielding of bars due to the shrinkage and creep effects. The maximum reinforcement limit is, in practice, it is only 3 to 4% is used as a maximum limit. However, a reduced maximum limit of 4% is recommended in general for better placement of concrete, particularly at spliced locations. As per SP 24/1983, it is suggested that the minimum limit will be that the corresponds to the pedestals as 0.15% of the gross area. In any column that has a larger cross-sectional area that required to support the load due to the architectural considerations for meeting local building regulations or to use standard framework or molds, the minimum percentage of steel shall be based upon the area of the concrete required to resist the direct stresses and not on the actual area. The minimum number of longitudinal bars provided in the column shall be 4 in rectangular columns and 6 in circular columns. The bars shall not be less than 12 mm in diameter. The minimum diameter of the bar, that is 12 mm, is based on the requirement of the stiffness and not on the strength and the type of the steel is used. For the sections with several corners such as L, T, plus, at least one bar should be provided at each corner with proper transverse reinforcement. A reinforcement concrete column having helical reinforcement shall have at least 6 bars of longitudinal reinforcement with the helical reinforcement. In a helically reinforced column, the longitudinal bars shall be in contact with the helical reinforcement and equidistant around its inner circumference. The spacing of longitudinal bars measured along the periphery of the column shall not exceed 300 mm. Why do we provide the transverse reinforcement? The transverse reinforcement is provided to provide shear and torsional resistance of the member, to confine the concrete core, to provide the lateral resistance against buckling to the longitudinal reinforcement, and to help keep the longitudinal reinforcement in place during the construction. The pitch of transverse reinforcement shall be not more than the least of the following distances. 1. The least lateral dimension of the compression member. 2. 16 times the smallest diameter of the longitudinal reinforcement bar to be tied. 3. 300 mm. Out of these three distances, we consider the least one. Diameter. The diameter of the polygonal links or lateral ties shall not be less than 1/4 of the diameter of the largest longitudinal bar and in no case less than 16 mm. The pitch and the diameter of the transverse reinforcement are shown in the form of pictorial diagram. Here in this diagram, it is shown that tie diameter, that is the lateral tie diameter phi t, is greater than or equal to phi longitudinal, that is the maximum longitudinal diameter of the reinforcement divided by 4 or 6 mm. The tie spacing, that is the lateral tie spacing that is denoted as ST, which is less than or equal to D, that is the least lateral dimension of the column, 16 times the minimum longitudinal diameter of the reinforcement, and 300 mm. The cross section of the column is considered is as follows: the width of the column as 400 mm, and breadth of the column as 350 mm. The reinforcement details are given in the cross section. Here in this, 12 diameters and 16 diameters are used, and 8 diameters 8 diameter is used as a lateral tie. Now, to calculate the tie spacing, we consider the least lateral dimension of the column. Here in this example, the least lateral dimension is 350 mm. Next, 16 times the maximum, 16 times the minimum longitudinal reinforcement. In this, the two longitudinal dia is used. One is 12 the other one is 16 So that is 16 into 12, that is 192 and the third one 300 So out of these three, we consider the smaller one. So that is the tie spacing is less than or equal to 192 Coming to the tie diameter, the minimum tie diameter is 16 that is the maximum longitudinal reinforcement diameter that is 16 divided by 4 is equal to 4 and 6 So whichever is greater, we consider that as a tie diameter. So it should be more than that, more than these two values. The maximum tie diameter is not specified in the IS456, but it is better to restrict the size of the lateral ties to 16 The hook of the lateral tie is provided as 135 degrees rather than 90 degrees. 90 degrees is the wrong practice and 135 degrees is the right practice. And the extension of the bar is 10 times the dia of bar, or greater than or equal to 75 If there are four longitudinal bars in a column, a periphery closed lateral tie is required to prevent buckling in both the directions. When there are more than two longitudinal bars on one face of the column, if the spacing between the bars is not exceeding 75 only alternate longitudinal bars need support. So this one and this one need support. If the longitudinal bars are spaced at a distance not exceeding 45 uh, times the diameter of a tie, or effectively tied in two directions, additional longitudinal bars in between these bars needs to be tied in one direction by open ties. If the longitudinal bars are spaced at a distance of more than 48 times the diameter of the tie, then closed ties for internal bars will also be required. If the longitudinal bars of column are placed in more than one row, then the transverse reinforcement with the above criteria and the inner row longitudinal bars are spaced more than 3 times the diameter of the largest bar of the inner row from the nearest compression phase. So this is the nearest compression phase. When the longitudinal bars are grouped and each group is adequately tied with the transverse reinforcement, the transverse reinforcement for the section as a whole may be provided on the assumption that each group in a single longitudinal bar for the purpose of determining the pitch and the diameter of the transverse reinforcement. The diameter of such transverse reinforcement need not exceed 20 The helical reinforcement shall be of regular formation with the turns of the helix spaced evenly, and its ends shall be anchored properly by providing 1.5 extra turns of the spiral bar, where an increased load of a column on the strength of the helical reinforcement is allowed for the pitch of helical turns shall not be more than 7.5 mm, nor more than one-sixth of the core diameter of the column, nor less than 25 mm, nor less than three times the diameter of the steel bar forming the helix. In other cases, the requirements of 26.5.3.2 of IS 456 shall be complied. The diameter of the helix re- the diameter of the helical reinforcement shall be in accordance with 26.5.3.2 C2 of IS 456-2000. The key takeaways from this video are the details of a longitudinal reinforcement, the transverse reinforcement, and helical reinforcement. Thank you, Jai Hind.